that's the result of the previous stream. So we had two patterns. Both are defined just by texture. So take a look. There's a material. MI, or was it halftone material instance? Ah, just the name is wrong. Okay. And just by replacing the texture, we replace the response to lighting. But is it actual lighting? Because if I was about to add a light, point light, as you can see, nothing reacts to it except for this little shiny cube, which is default PBR. Everything else just ignores it. So why is that? Is that it's like that because we have a fake light, or everything is fake in computer graphics, so a manual light. So take a look. There's a point light position. Click it, move it, and the light is moving. So is it actual light? I think yes, because lighting in games is implemented in the same way. So, and in shading models in general, like fog and stuff, or actual Lambert. Take a look. There is point light position in workspace. Then I subtract the position of the pixel on the surface of the object from it to get the kinda direction from light to that object. I normalize that to make it sure it's a direction, not a length, not an offset. Because normalize changes a vector into a unit vector, meaning it represents direction. So any vector you take, normalize it, you have direction. Dot product between that vector, so like light direction, compared with pixel normal workspace, and clumped, gives you the light intensity depending on the angle towards the light. And then another thing is 1 divided by square root of distance to that light from the surface gives you the light fall off, the intensity by distance. That's it. You multiply one by the other, here you go. And then you just remap it by a custom ramp, and we feed it through height rep to get this really nice texture. If the texture wasn't there, let me show you what would happen. Let's say there's the texture, right? Let's just take some grayscale one. This. It will just look plainly like this. Cut off at some point. We always cut off at some point thanks to the ramp, the low remap stuff. But with the texture, the cutoff point is slightly shifted depending on the texture value. So we just, height behaves like subtracting the stuff or something. So if I replace that with the halftone points texture, this is what I'm getting. In the places where the light intensity is like strong, and the more darker pixel here, it still gets above the threshold, right? So the darker the shade of the light, the harder it is for this texture to go above the threshold. Threshold implemented by remap. So that's it. Color void asks if that we wanted control over light direction. Yes, Roy, that's a good point. I didn't know that because I implemented directional light manually. In the same manner, directional light is similar, but even simpler. It's just a constant direction. So not direction to the surface, just constant direction normalized, and then compared with pixel normal. But what Roy says is that we can take light direction, sky atmosphere light direction. Okay. So just put it through here. That's what you mean. Apply. Okay. And where is my light direction? Light source. Doesn't work. Or it does. Okay. Very cool. Hey, it actually works. Thanks a lot. Good to know. So there is a node, sky atmosphere, light direction. Nice. Okay, let's revert this there. Perfect. That one. Okay. So let me take a look at this Discord. Yeah, One Eye did a great job here. Oh, and there's also a benchmark you can check by Ezekiel. So this is a benchmark based on Unreal Engine 5, testing these new features, testing virtual textures, nanite and stuff. So my laptop got beaten up by this benchmark. It's intentionally heavy, but I got 2.83 FPS. Fantastic. In Full HD. The benchmark is called Easy Bench, and you can find it on Steam. Easy Bench. It's free. Okay. Where were we? Oh, Wana, you are here. Welcome. Let's go higher. Yeah, so this is what we tried. Ape out the paper texture. That's here. Entity. This may be a good one to try. This may be too hard for now. I don't know. There are fake ways to do it, like cheap ways and proper ways. Cheap ways are median filters, and proper ways are particles. Oh, Tsupak says they want to keep their PC for a while, so they skip that benchmark. The benchmark is hard, that's true. Actually, I may show you the cheap version of that painterly stuff. There are actually two cheap ways, flow maps and median. Let's start with a median. But we may need some better scene with some colors or textures or something. And we don't have it, or do we? Or maybe let's add some colors here. Actually, why not? Okay. Let's do it. Though to show median filter, we would need some thin objects and some maybe cutout textures or something like this. Okay, for now, let's check what we had so far. But I think not much there. Okay, just global weather, pretty shaders. Okay, let's stick with this one. Just let's add some more colors to it first. Let me disable that ugly atmospheric fog. Okay. If I delete it, will something bad happen? No. Okay. Now, I would like to welcome some fog. So add visual effects, exponential fog. Okay. Where's the fog? Fog density, x3. What? That's the fog. Volumetric fog, maybe? Yes. Yeah. Okay. But the fog is still pretty bad. Fog fall off. Fog fall off. I guess. You know what? Let's use one of our other shaders, this iridescent stuff. Iridescent metal. Okay, cool. This could be bigger. So scale like 8 and 8. Center Oh no. What? Huh. I centered it with the power of maths. Okay. I can still see the edge, so it's not good enough. Now it's good enough. Okay. Now what I would like to do is to add some color. So let's go back to the material. There's this paper texture stuff. It all goes to emissive. So we have to multiply the color of light by something. I think, yeah. Yes, yeah. So, I would like to have base color, let's say. Can be whatever. Very bright. Multiplied by what? Multiplied by this. Okay. Good. Let's try. Yeah. So I just multiplied the lighting result by albedo, right? However, for the directional light, I would like to have a separate color. So directional light is here. And multiply vector directional, whoa, light color. And let's say directional light will be slightly warm, like this. Let's try. It works. Now the brightness of this directional stuff could be bigger. Whoa. It's not that material. Okay. And we could add some ambient light. So ambient light is easy. You just add. Of course, it would be better to use ambient occlusion and stuff. Do we have ambient occlusion? Occlusion. Orc. Damn it, AO. We don't. I thought we could add this, get this distance field stuff. Nah. Okay. Distance to scene. Distance to near surface. Maybe pre-computed AO mask. Pre-computed AO mask. Thanks a lot. Let's see how it looks like. It's just dark. Let's hide that light source. No, the fog. Where's the fog? Where's the fog? Go to lighting. Ah, dark. But maybe we need something like distance field AO or something like that. Distance field AO. Where are you? Ah, we may need a movable skylight for that. Movable. Distance field. Isn't there something like that? There was. It's light map AO. Okay. I thought it would be distance field AO. But do we have distance field AO? Like show, visualize, distance field. Yeah, we have. We do. Oh, by the way, this volume is so shitty. Why is it that bad? Distance field resolution 2. Show the use 4? It's too much. 3. And apply. Huh. Wait, this one is different. Why? Because they're unlit? What the hell? So unlit materials are so shitty in ambient occlusion? What? Actually, why? What is the reasoning? Default lit, normal, beautiful. Unlit, crap. And casting weird shadow. Scene texture material AO says color void. Scene texture material AO. Color. Comparison errors. Ah, because it would have to be transparent. Because scene texture reads from the stuff behind that object. So I could use it, but in a post process. Oh, yeah. And it won't give me my own AO. Let's see. Delete that. Why don't you delete? I pressed delete. Come on. But can you see that? Like unlit stuff, ugly, weird on sign distance fields. And then I convert them to default lit. And it's magic. Like, super good. You know. What the hell? Because I would like to keep my stylized stuff. You know. That's so weird. Yes. Visualize. Yeah, no, they're normal materials. Great. But I wanted my effects. What can we actually do? Is there any... Okay, let's try another thing. Actually, I don't care about this because then I won't have any AO at all. If I used, again, visualize distance field stuff. If this was unlit but transparent, what would happen then? Translucent, for example. Black. What? Ah, because the floor is black. Okay. The floor should be standard for now. Okay, they're just black. Okay. Masked. Masked unlit. Bad. Opaque unlit. Bad. Two-sided maybe. Nah. Without ray trace shadow. And default lit. Perfect. What the hell? Okay, let's don't care too much about this distance field AO. What we should focus on is going back to this unlit stuff. Sorry, it's a shame, but we won't have ambient occlusion. However, we could have baked it, right? We can bake it. Let's go. What's the good baker of ambient occlusion these days? Substance? Let's start Substance. Let's go to Stylized Art. Content. Models. Where's the model from? Model should be Ticket Projects Common. Models FBX. Yes. I think so. Is it that one? Wait a second. This model, this one, is shader test sphere. Okay, coming from test sphere is different one. Basic shader test here. Oh, it's this one. But I imported another. Oh, dense, exactly. Let's replace that stuff. Great. And let's bake some AO. Link as UD mesh. It doesn't have unique UVs. What? Again, Blender. No. Ah, it's not Windows 11. I cannot snap to corners. Oh. Okay, come on. Good. Let's open. Where was it? Open. Models. Test sphere. 12, but dense. Huh. Modified in 2016. I didn't save it. Oh no. I need to import that stuff. File import fbx. Yes. Date modified. Dense. Exactly. Perfect. And now save it. Save it there as shader sphere. Dense. Okay. Not cube, dude. As no, how's it called? Like that. Great. So now let's check the UVs. Aha. So let's make another UV map. Oh, light map is there already. Good. Let's back to this one. I don't need to change it. Okay, so how was baking? How did baking work in Designer? Bake model information. Okay. Okay. Where's UV set 1? PNG, yes. Where did you set the types of baker? Here. Okay. Ambient occlusion map from mesh. Or just ambient occlusion. Let's try small first. So start render, I guess. Okay, cool. Very fast. Looking good, though maybe denser. What's this point? Can I preview that? I think I can. I can just drag and drop. No. Drag and drop here. Yes. And now I can drag and drop this AO as AO. Oh, but come on. On a different UV channel. Edit the shader. There's no UV channel selection? Come on. Why? Hey, that's unfair. Whatever. We'll check in Unreal. But I wonder about the black dot. What the hell is that? And let's start. Let's try it in Unreal. So first 1K. Then ignore backface. Yes. Bigger frontal value, maybe. Let's try now. I'm not sure, to be honest. What is this frontal value? Is it the distance of the ray or? I can't see any difference. Okay. Dilation width 16. Maybe more, 32. Why do you limit it? So why do you limit that? High. There was an RTX based baker, but maybe I have a too old version of this. Should be just O. And why does it convert the name to small letters? Okay. Are there any options like cosine or something? Use low as high. Yes. Looks good. Let's just save it. Save baking setup. Close. Delete that. Rename. Shader test sphere. Of balance. All. Okay, let's export that. Show in Explorer. Actually, yeah. Save all. Good. Let's try it in Unreal Engine. UE meshes textures. It should be grayscale, no sRGB. And now in the stylized paper, I can have a texture sample param. Texture sample parameter 2D. Ambient occlusion. It's there. And for the UVs, UV 1. So there should be some parameter like switch, static switch, static switch param. Hey, come on. Static switch parameter. Should be called use UV2. Ambient occlusion, use UV2. If it's true, then this one. If it's not, then 0. And let's visualize that. It's just a baked texture, right? Nothing fancy. Fantastic. Enable. Okay, looking good. Actually. Looking good enough. So now, take a look. I will make a... So ambient light is basically just a constant light. So ambient light is just some color constant multiplied by ambient occlusion mask, and that's it. And just add it to the light, to the total light. So see, kind of ambient. I can make this darker, subtle, and I just add it to the total light. So add this thing to whatever we had so far. Save. That was pretty bright, but that's because our base color. Actually, why? Let's detach the ambient for a while. It was just that bright, okay. So I wonder, because there's a base color. Ah, there's some add leading to nothing. Add one. Yeah, now it works. So as you can see, we have this ambient stuff, it's not black. At the same time, there's added point light. Oh, point light should also have a color. So let's multiply the point light energy by point light color. And this point light color, of course, can't be black. So let's make it something. If you make them red, orange, that's what happens. Now the base color could be a texture. Oh, could be. But we don't have any good textures, right? If we make it gray for now. Yes, we have reddish point color. Can make it actually red. Like this. We have directional, which has quite a neutral color. We can make it brighter. So directional light, where are you? Directional light. Intensity. Okay. Here we go. So as you can see, two separate things. Plus this ambient, right? Just added. So we implemented a basic lighting model. A complete lighting model. Well, not complete, without specular. But let's not focus on specular too much. Let's go back to our halftone. Oh, halftone variant. Here it is. And let's make this directional stuff brighter. Okay. Just like this. So here we go. Let's go back to it. And yeah, these are, nothing changes because they're unlit. It's our own lighting model. Only thing that changes is tone mapping. Right. Cool. So we have that thing. Now the floor. Let's do it paper. Let's assign the paper again. Cool. The directional response is very strong. What if we just rotated it a little? Huh. So that's what happens. You can see how the light is moving there. Right. Though for this background, I would probably need something more subtle to show you the median filter. So let's go back to it and just let's replace that with grid for now. I know the grid is not that beautiful. Oh, light color could be white. Okay. I need a more intense grid. Wait a second. This one is quite harsh for the eyes, right? Though maybe, actually. Wait a second. Do we have skylight? Yes, but it doesn't have any cube map, so let's use some cube map. White cliff top. Ah, but for the skylight, we don't have a sky sphere. Huh. Okay. Sky sphere. Where were you? It was in the meshes. Sky sphere. I swear it's somewhere. I had that. Or maybe it was in... I really have it. I sphere. Okay. And the material would be MI Arista rec. Okay. I don't like the edge. You know, I really don't like the fact that we see the sharp beach behind it. Let's bring back the fog. Perfect. Fog density maybe not that extreme. No, it's pretty good. And this one could be slightly bigger. 24, 24. Good. So we have our scene with some sharp detail here also. So let's implement a filter that will slightly move us towards this direction, okay? So it will be a post-process. Let me check one thing. Oh, by the way, let me turn off the light because it's quite blinding. Better. So the material. To apply post-process, you go to post-process volume. You find post-process material somewhere. Oh, here. There's an array of materials, empty by default. Plus asset reference. And then you can select the material. It's not just any material, it's a material that operates on screen color. So in the stylized art, right click, material, M, post pro. Oh. And it will be oil paint. Okay. Drag and drop it here. Of course it doesn't work. So you have to change the domain to post-process. And now domain is post-process. Dark. Nothing's there. That's because our post-processing material has emissive color that's 0. So, okay, we can put a color there. Constant. There's something, right? So we can put, for example, viewport UV, screen UV, screen position. And we have this. So this already would allow you to read the texture and do something with it on the screen, right? But first, what we are interested in is add these UVs, read the screen texture, the color. So scene color. It takes UVs, so you give it to it. Okay, and that's it. Put it to emissive color. Sorry, not scene color. Scene texture, I guess. Yes. What? Only surface material domain? It was something else. What was it? It has to be scene color. If not, then what? Post-process input 0? Okay. Okay, here's our scene. But now, take a look. If we add something to these UVs, add 0 and offset X, offset Y, append, and add it here. Nothing? What? It's to apply 0.1. Yeah, so as you can see, the texture is moving 0.3 and so on. So we can modify the UVs where we read the screen. If we don't do offset, but if we do scale 1.2 and just multiply these UVs, or first subtract half, right? Multiply that, and then add half again. So subtracting half makes it center not around the corner of the screen, but around the center of the screen. Thus. And then you add half. Nothing changes. Scale 0.6. And you have a zoom. Now 0.3. Right? So by scaling the UVs, so you by multiplying the UVs, you scale them. By adding, you offset them. And that's already something. So if you wanted to do a barrel distortion, for example, you would scale the UVs higher at the edges. So you take a distance from current viewport UV to half. If you visualize the distance as color, you can see it's a gradient. Now aspect ratio is important because this is stretched. So, so you take screen. What was it? Screen resolution? But there was aspect. I think there was something. There was viewport, view property, view size, I guess. I'm not sure right now. But I think yes. And you do component mask X, component mask Y. You divide one by the other. So you divide this by that. And you append one and this thing. So this is aspect ratio. And you just multiply the viewport UVs by that. So multiply the viewport UVs by that. And then put it into distance. Ah, that's bad. Multiply after the subtraction, of course. Multiply this. Then multiply by scale, which should be 1. Then add. Okay. The aspect ratio stuff didn't work. Wait a second. Not connected. So yeah, subtract half, multiply by aspect ratio, multiplied by your desired scale, then add half again, and then measure the distance from half, so from the center. Let's see. Maybe it should be the other way around. What? Or this view size doesn't work as I expected. Viewport size or size. Scene textile size. Is it aspect corrected or not? View size. So this view size should work. But there was also a difference between viewport. Oh, can you see that? Maybe it's just inverted for me. Maybe it was okay. I just need to replace. I don't get it. What I'm doing wrong? I'm dividing this by that. Oh, multiply. Jesus. Append. Okay. I need to have 1 in X and the ratio in Y. Now it works. Okay. So take the textile size. Yeah, now independently on the ratio, it's still good. Without it, we just get without it, if it's a 1 and 1, it gets stretched, right? So it's mapped to the size. And now it's independent if you do this aspect ratio trick. Cool. Okay, so we have that. So now we have a distance to the edge, right? I want to do bar distortion. So we can lerp between two scales. Scale center, scale edge, lerp, well, lerp between them using that gradient. So here, let's remap this because remapping is important. Remap value. So it will be from actual 0 will be the center to some radius max, which will be in UV space. So let's say half. Remap this to 0 to 1 and saturate it, meaning clamp it between 0 and 1, and then use the lerp between those two scales. Okay, so we have that stuff. And then we can repeat this. Do we need aspect ratio or not? Oh, wait a second. Let's have something like, so this, wait, I subtract half. Ah, okay. So named reroute, and this will be aspect UV aspect corrected. And this UV aspect corrected are calculated here. I check the distance from them. Then I should, yeah, this is the radial mask. Radial mask, but remapped. Whoa. This stuff. Radial mask. Let's output it as a radial mask. Radial mask. Good. And now I'll take this lower, take my radial mask. It's here. Take the UVs, the UV something something, aspect corrected. And now I will scale them. Ah. If it's aspect corrected, it can be already centered. I don't need that. Let's rename it. UV centered or 0 centered. Aspect corrected 0 center, meaning a 0 is at the center of the screen. So here I have my radial mask from 0 to half. Yeah, now it makes sense. And here I have my UV aspect corrected 0 centered multiplied by that differing scale. And based on this, I can actually display them. Let's first display the standard UVs, aspect corrected UVs. So that's how they look. They actually have 0 at the center. Now they increase towards the right and down, and on the left they have negative values. If we were to take a fraction of it, an absolute, you could see what's going on. Yeah, so here they are. So now I have this radial mask, it's here. Whoa, wait a second, something's wrong. Okay. What's wrong? Nacho asks if we are doing a post-process effect right now. Yes, yeah. I'm showing basic of post-process effects, but I don't get it. I have my UV 0 centered, this thing, right? And I just took it through distance to half. Sorry, distance to 0, of course. Radial mask. So radial mask is just taking these UVs, remapping them from 0 to half. And what? Nothing? Ah, here it is. Okay, now it makes sense. So as you can see, radius mask shows us where the gradient will end in the UV coordinates. So half meaning half of the screen. And thanks to this, oh, hey Adler, we are doing a basic post-process. So again, aspect ratio is important. Just keep this this formula. I pasted on Discord in live stream chat for post-process. And again, Discord invite. Where's it? Here. Cool. So this aspect ratio. Then you subtract half to get 0 centered UVs. Multiply them by aspect ratio to get aspect corrected. And then I calculate radial mask because 0 is actually in the center, not in the corner. So I used this radial mask to do a barrel lens, kinda. So typically we have the post-process input. We have standard UVs, so screen position. Post-process input 0. You do it by adding scene texture and selecting post-process input 0. And put it the color into emissive, and here is your scene. Standard scene, without anything. If you, of course, multiply it by some color, right, you will have what? By vector 4? Append alpha. Append alpha of 1. Beautiful. We multiply the scene by a color that is brighter than 1. That's a very good trick. You can also multiply by negatives, like that. Here you go. Okay, well, let's delete that. Let's keep just the raw plain scene. And now I have my aspect corrected UVs. I have the radial mask, so I will change the scale with which I multiply these UVs. At the center will be 1, at the edge it will be 1.1. Multiply them, and then I need to bring them back to the center. So add half and half. Okay. And let's use them as the UVs. Whoa, that's weird. That's not what I expected. Ah, if this is 1, does it work? No. And why not? I multiply them by 1, so they are 0-centered, aspect corrected. Ah, because they are aspect corrected. So I should undo all this. No, I will just take the screen position, subtract half, do this math and add half. Okay, so now at the edge I want to have a scale of 1.2. Here we go. Maybe 1.8. Here it is. So as you can see, a fisheye effect, right? So we have this radial mask thing, and this controls our scale of the UVs between 1 and 1.8. Of course, we need to cut the screen later. Where was it? Here. Yeah. Let's go to the extreme. 4. The image is becoming smaller, the effect is becoming stronger. But you will need to scale the entire thing later. So for example, instead of 4 and 1, rather something like 2 and 4. No, not that way. Rather something like keep that at 1 and this like half. Yeah. Now you are safe because you don't exceed the edges. Of course, linear gradient is not a fisheye. So take that radial mask and do something with it. Ideally, take a power, take a square root. Because if we open GraphToy, yeah, what? Yeah, you have some x, right? X, now clamp this x between 0 and 1, which is very important for the trick. And in the area of 0 to 1, if you do square root, this is what happens. The same is power to half. It's the same thing. Power to 2 is the opposite direction. Power to 4th to 8th to half, 0.25, 1.25. Yeah. So this changes the, the straight thing is changed into a curve. So square root of radial mask will give us nicer behavior. Now you can see this egg-like shape. If the square root is just better. This is bad, right? You can look at the grid basically. Let's take a look like this. Can you see how it is? And now with square root, or maybe the square root power of 2. Wait a second. Yes, yeah, power of 2. Just looks better. So that's a fisheye, right? Scale center can be not that extreme, something smaller. 0.8. So here you already slightly stylized graphics. But what I wanted to show is how to make a blur filter. Blur filter. Of course, blurring is hard. Yeah. So that's the fisheye thing. Let's actually rename this because it was supposed to be oil paint, but I digressed into a fisheye. So mpost fisheye. Good. Let's duplicate it. and do mpost pro oil paint. Exists? Okay. By the way, I will have to go soon, so let's be quick with that. So back to our normal UVs. Screen position UVs. Okay. You can see we have some pretty sharp shapes. So in order not to have pretty sharp shapes, what we can do is for each pixel, like this, we can take its neighbor to the left, neighbor to the right, some neighbor to the top and bottom, and ideally some corners. And they will have different values, right? They will have some bright values, then something gray, and then something dark, like here. So we may take an average or median of all these, and then assign it back to the pixel. So that's how most blur operation works. Basically all operation based on kernels in graphics. So the kernel is the collection of that samples. So what we need to have is the number of points and the distance to that center pixel. So let's make it. We have screen position viewport UV. Viewport UV is from 0 to 1, not in pixels. This is in pixels. So we may either divide viewport UVs by screen size, I mean pixel position by screen size, or divide the pixel size by the viewport size to have this tiny fraction like 0.001. So let's do the second option. It's called view property, and you select the property here. Select, or no, maybe I'm wrong. Wait a second. I'm wrong. It's not this view. It's scene pixel size. So basically, if you want to shift to the one pixel to the right, you can use this. And this is also, this has two axes differently depending on the aspect of the screen, which is good. So let's implement a very quick chromatic aberration, and then we'll go to actual blurring. So take a look. Oh, Ryan Hawkins, hi. Welcome. So take a look. Screen position. Let's add to it, taking the syntax size multiplied by aberration kernel size. This kernel size is just, you know, what I show you. This radius. Do you want it tighter or wider? So these offsets will change. So look, aberration kernel size multiplied, added to the UVs. By default, 0, let's say, and take a look. We take this scene post-process and multiply it by, come on, multiplied by yellow, okay? The two channels are in G, and we multiplied again with different set of UVs with the remaining channel being blue. Put it there, color, and then we combine them. They're exclusive, 1, 1, 0, 0, 0, 1. So we just add together like this. Of course, append alpha. Ah, this is float 4. Okay. Component mask as Adel suggested. Comp mask RGB. Okay. So why do we have 2 instead of just multiplying? Because we have different set of UVs. These are the straight UVs, and these are the shifted UVs with this aberration kernel size. By default, they will be the same. So the image will be complementary. Red 1 and green 1 plus blue 1 will give us neutral image. Let's try. Standard image. However, now we increase the kernel size to 5 pixels. Can you see that? Can you see the effect? Now let's do 20 pixels. Is there VHS effect? Okay. That you can see it, right? Let's swap the colors. Let's do this will be only red, and this will be green and blue. Here we go. Stereo. I don't know how was it worldwide, but in Poland we had this books for children showing dinosaurs in 3D through the special glasses. Okay, so it's not fisheye. I modified the fisheye. Oh no. This was the fisheye. Okay. Let's rename them again. So this Post Pro oil paint is okay. So again, close it, close it. Post Pro fisheye is Post Pro chromatic aberration, and oil paint is fisheye. Come on, redirectors. Fisheye. So now having this, I duplicate it again and do Post Pro oil paint finally. Ryan Hawkins is just lurking on the hunt for more Pokemon tech artists to acquire. Don't mind them. In the US, we had the cross-eye chromatic aberration books, that when you cross your eyes, the shape would appear. Exactly that thing, yes. There are 2 variants, with and without glasses. So this works. Okay, so again, the oil paint stuff. Let's go to global post-process. Drag and drop the material here. Let's open that. Okay, so now knowing that we can assemble the image from multiple samples, imagine that we sample, but this isn't just add in one direction, we add in 2 directions. So we have our viewport UVs. Then let's do kernels. It will be -1 and 0. So -1 in X, 0 in Y. 1 and 0. 1 pixel to the right, 0 to the top or bottom. 0x, 1 to the top. 0x, -1. Actually, in Unreal it's that way. Okay, 4 samples. And then we may need some more, because the effect would be very crude without it. So basically, how is it? 0707? Something like that, right? Let's do 07 to simplify. Then it will be 0, it will be 0707. Okay. This will be 07 -07. 0 and 1. No, the other way around, sorry. Yes. And this will be -07, 07. We covered the samples. So now we take this screen position stuff and we add to it. So take this, add this also to the center, the neutral, but we don't care. Add 8 times. We have to probably shape them in the same way. Adds will also be placed like this. Okay. And just to each viewport UV will be added an appropriate kernel size. However, this is not all, because we need to multiply them. This, right? We need to multiply them by kernel size. So kernel size, effect kernel size, multiply by, yeah, that becomes tricky. Multiplied by this. Why do you disconnect? Come on, don't disconnect. It's like that. Yeah, that becomes messy, I know. And we could do it with a custom node, or there's even a special node, samples something. But I just want to show you the principles. So we multiply each offset by the kernel size. Okay. This here. Piatnashkin says 0.7 is close enough. Okay, we multiplied all of them. And then we add this offset to the viewport UVs. So viewport UVs plus this one, that one. Here we go. Okay. Finally we have them. So these are offsets created by kernel size. These are final UV for samples. Great. And with this, we can have multiple post-process inputs. Sampled again. So I know it's becoming messy, I know. So this will be 1, 2, 3, 4, 5, 6, 7, 8. Top one, northeast, east, southeast, south, southwest, west, and northwest. And out of these, we take an average. So we add them together. 7 adds. Okay. Add them like this. Now, of course, their sum is bigger, so we just divide them by the number of samples. Number of samples is 8. So it's like calculate average. Calculate average. Div by number of samples. Okay. So we just divide that by number of samples we've taken. And this gives us an average of all these samples. So now let's take this as the output. So you know, 8 points, then average. Here we go, nothing happened because kernel size is 0. Let's do kernel size 3 pixels. Oh, it's not pixels. Yes. Pixel size, sorry. Pixel size. It's at 3 screens right now. Multiply that. 3 pixels. So again, 0 pixels, 2, 5, 15, or 16. Here we go. So we have a blur. The blur, of course, is not a perfect Gaussian blur. For that, you need not a post-process material, but a render target. Because to do a proper Gaussian fast, you just blur the screen in one direction, save it, and then blur it in the other direction. And this is mathematically identical to taking so many more samples around, but way faster, like way faster. Because if the filter is symmetrical, then it's possible. But here is just a simple effect, brute force, 16 samples. It's not a box blur, like omit. A box blur will be if we had only this samples. It's a box blur, 4 samples. This is a radial blur, no, circle blur. It's not a disk blur, because for disk, you would also need some samples in the middle, at least one, but probably more, to cover this area, you know, like this. But yeah, it's a blur that takes a ring. Looks fun. As you can see it with these dots, they look like circles. Legomit will check the proper definition of what kind of blur it is. Ryan Hawkins says my eyes. Yeah. But you know, we have it. Finally, the oil paint. What could we do? We have these offsets, right? What? Not connected? Is adding 1? What the hell? Yeah, now it's better. Okay, that was a mistake. So we have this blur. Now oil paint. We have the samples, right? So what if? Just what if we took this kernel size and multiplied it with, guess what? A texture. So let's go to noises. Pick something. This one looks good. And take a look at this. We have our viewport UVs, right? So let me detach it for a while. Viewport UVs, screen Vs, screen coordinates, screen position. Okay, viewport UVs. Here they are. Let's use them, but multiplied by text styling and multiplied by by text aspect ratio. Again, 1 append divided and put it here. So text styling will be 1 by default, aspect ratio 1. We had aspect ratio somewhere. We do. Okay, so we'll multiply by aspect ratio. Okay, neighborhood aspect ratio. Okay. text styling, multiply again. We may need it zero centered first. We had zero centered aspect ratio corrected. Zero centered aspect corrected. Yeah, I made it. Just multiply it by text styling, sample the texture with it, and let's see the result. Here it is, a texture on the screen. Bigger tiling. Here we go. Right? So what if we took this texture? This is a normal map, by the way. It's not sampled as a normal, so we need to remap it. First, let's just take component mask only of R and G, because that's what we need. Like this. It looks similar to the codes in our UVs, right? So imagine we can multiply that by text strength for example half. Okay, we need to center this around half, so that's from -1 to 1 instead of 0 to 1. So let's add, let's subtract half. Or actually first let's multiply it by 2. Yeah, multiply by 2, subtract 1. Multiply by 2, subtract 1. To make it from -1 to 1. Okay, and then we scale it. So this stuff, remap to -1, 1. Good. So now it will look like this. We take our viewport UVs, so in position, and add this stuff. Now take a look. Texture strength 0. Texture strength half. Right? Distorted UVs. So this will be... can I make a comment? These distorted screen UVs. So this will be texture sample param. Distortion text. Using that one. Yes. This will be distortion strength. Save it. And now we sample using these UVs. So we take scene texture using these UVs. Post-process input 0. Here we go. Super strong. Looks like frosted glass. So we go to our distortion strength and set it to somewhat small, like 0.01. Here we go. Of course, the paint distortion is attached to the screen. There are ways to fix that. Explained in the previous one. But you know, it works. So now it's too sharp, right? So let's go back to our kernel. So we have to take all that but we don't want to do it so many times, right? So here are our distorted UVs. Let's bring back the blur and let's just connect this distorted UVs. If a kernel size should be there, that's good. Connect this distorted UVs as normal UVs here. So name reroute the UV distorted. Oops. And just replace it. Let's try now. So as you can see, oil paint, but nice and smooth. That's it. So again, the final material is there. And if you want to have the project files, then guess what? Patreon.com, Deckard 8. And here we go. So the middle one and the last one give you the project files, and both of course give you the access to the video of what we just did. So yeah, Janashkin says it's postal box blur with squash corners. Okay. So the final material is we distort the screen UVs, add the offsets, sample the screen 8 times, take an average out of this by dividing by 8. Here you go. Of course, the improvement could be to make this texture stick to the skybox or to the word instead of the screen. But you know, it's up to you to figure that out. Previous video contains some tips, as well as the live stream chat channel where Lilu posted this, and Sedokun also. Okay, so it was great to have you here. Here's the link to Discord. And what? See you next time. Cheers.